It's been really interesting listening to the other two speakers, because I was madly writing notes about data and sort of high level stuff, and Greg, I took some good notes earlier there about the U.S. market, because I'm madly trying to move our sales force from a real focus on the Canadian market and starting to look south, and it's been really interesting that we're owned by a company that builds condos in the Vancouver market primarily, and our board of directors always getting mad at me for not being faster into the U.S. But there's a lag, and 90% of our business is in non-residential, and I'm going to say 2 stories and under, which is against everything that I'm going to talk about. Mass timber buildings. So what I want to do today is sort of take you guys on a journey, and I had my phone out here earlier. I'm going to break all the rules and look at my phone while I'm here. I was when Fred asked me to talk at this session, I said, Fred, I can customize my talk to the group so that hopefully I can identify or give you guys some takeaway or some value rather than me just telling you a story about our company. And so let's just sort of see who's in the room, Fred, if I've missed anybody. Log home manufacturers, some timber framers, softwood mills, hardwood flooring manufacturers, some reman plants. I met Paul there earlier. Warren, we met earlier. Modular panelized home manufacturers, roof truss manufacturers, molding and millwork, kitchen cabinets, building supply wholesalers. There's 3 architects, some engineers, and some government officials. That makes it difficult to give you guys a takeaway for the whole group in 45 minutes, but I'm gonna do my best. And so let's sort of go on a journey here together, and please ask questions as we go. If not, if you're shy, we can have a discourse. But I'm going to take hopefully the information that Greg and my friend Dave presented, and I'm going to ask the question to those of you who are in manufacturing or in remanning or in architecture, and that is, what have you sold today? What did you sell today? Because with all this information, at the end of the day, I am responsible to a quota. My board of directors and my president wants to make sure that my team can continue to employ 150 families, 200 families that we have the honor of having worked for us in our 3 locations. So today we're going to start off with a little bit of a history of our company. If you haven't heard of us, we're not that big, and we're way on the other side. Our reach is global, but mostly we play in that sort of west of the Mississippi in markets. I want to talk about the journey from heavy timber that we've been talking about for years, and the timber framers in the room will understand what I'm talking about, to mass timber. And really, I mean, Chewy, we've seen that term develop in the last 6 years. It's really been a big shift. I don't know if that was Michael Green or who brought that term up, but there's been a shift from heavy timber to mass timber. We're going to talk about that. What does it mean? And really, I want to talk about that product maturity matrix. And so I'm really more geared to those of you in the room who are in manufacturing, in selling different types of product, whether it's finger jointed studs that Paul's going to get into, to glue lam, to all those sorts of different things. And from the visionaries and hacking our way through the jungle, getting across the chasm that we call it, and the different phases of a market and how it develops, and where I think we are today. Who knows? Right? Yeah. So I've had the pleasure of working at Structural M now for 6 years, but we've been in business since 1962. 2 brothers were in the construction industry in Penticton, BC, and decided that they start making their own glue lams rather than nailing wood together in their non-res and res construction. So we are a manufacturer of glue lam and now cross-lam CLT, cross-laminated timber. We've spent a whole lot of money in trademarking the word cross-lam. That is our now registered to us. So I'm going to say it, and hopefully over time you'll start saying it as well, and you'll start buying it. So we've been doing this for a long time, I always love to show the early development of it. Back in the day, big arches, shipping on trains. That load's going to Minnesota from little old Penticton out west. I believe this is the Korean Pavilion in 1976 in Montreal at the World Expo. And this probably is the most famous or most proud moment. I come from the city of Penticton where hockey is religion, and we are proud to have made the largest hockey stick in the world. And it can be seen in Duncan, BC now. It was made for the World's Fair Exposition, Expo 86 in Vancouver. So we've been doing this a long time, and we've graduated doing a number of different things. We're more than a manufacturer. This is a room that I have a seat roll. Thanks for joining us. I'm in a room full of people who, in theory, already love wood and don't need me to tell you why it is. But again, this is a picture of WITIC, the Wood Innovation Design Center in Prince George. We'll talk a little bit more about that later because we're pretty proud to be a part of it. But both David already touched on the strong, durable, beautiful, adaptable, sustainable. I'm going to also talk about cost competitiveness because, again, at the end of the day, I market and I sell all of the reasons that you should buy our product. But then at the end of the day, I still need to be competitive against, now my target's concrete, right? My target is not to ever steal one stick of wood from a fellow wood manufacturer. I want to take market share away from concrete with CLT. The sustainable thing about wood in general, I'm not going to touch on this. We all know why wood is great. I believe that was Michael Green, a relatively famous architect from the West. 40% of energy is construction responsible for 40% of energy consumption and 40% of greenhouse gases. And really, my whole target in my life today is to target that giant market called concrete non-residential construction and replace that with glulam in the frame and CLT in the rest of the building. The structural lam products, we have about 150 to 200 employees depending on how busy we are. We have 3 facilities, and we do everything from finger jointing. We make glulam and we make CLT, and we combine 3D modeling with CNC manufacturing. So I hope that's going to work. But really, truly, since the early days, we manufacture glulam. We design and supply heavy timber to that sort of timber frame market. A lot of the traditional timber framers turn their nose up at glulam because it's not pure. So we looked after that market as well. And then we're also I think we're the only certified deep gluer of commercial Paralam in North America. So we have a partnership with Weyerhaeuser. So we do a lot of remanufacturing of Paralam for large trusses, large buildings. So what, glulam? Paul, you're here somewhere. You're talking about, potentially getting into the manufacturing of glulam. It's been around for a long time. It's a mature product that's had a rebirth, which is pretty exciting. A mature product that's had a rebirth, and we're going to look at that maturity graph, the product maturity graph. We're doing, we don't do a lot of commodity type glulam. Greg, that in the two-step distribution world, the number one competitor to LVL is glulam. On the West Coast, we call them the I-fibers. Up and down the I-5, there's some very, very, very good laminators. They've been doing it for a long time. They pump out 1 million feet a day. Again, the numbers in EWP and volume are nowhere near what a super mill does in lumber, right? A big day for us is 100,000 board feet of EWP. A big day for the mills I used to run are 1 million feet. Man, right? Like, more than that. Yeah. Okay, so, but really, some of the projects that we get involved in, we're making one-off custom beams. We don't hold stock. We don't start manufacturing until your building is almost ready to go, and we've done drawings, and your architect and engineers have signed off on it. We've cut to length. we're milling, we're drilling, we're pre-finishing. We are sending you a massive Lego kit on site that goes up with a specialty group of installers. I don't know if you guys remember, we'll look at this in a little bit. In the early 90s, we went from hand framing and supplying sort of pieces, we call it stick, pieces of cut-to-length glulam. We started getting into prefabrication and got pretty much 90% of our business was going to Japan. And Japan was shifting into EWP type construction, Mabashira, Hashira, all these different types of post products, and they were importing it from North America, and we were lucky enough to be a part of that. And in the 90s, 90% of our business was over to Japan, so we cut our teeth on their tolerances. Greg, you were talking about earlier how pre-manufacturing has a really hard time blending with concrete slabs that aren't always true. We have one of our biggest problems about having buildings that are hybrid, and I'm sure in North America we're sort of seeing where CLT fits and how it reacts. Where does it make sense in a building to use mass timber? We're still just at the beginning of that. And when wood and steel and concrete go together, there's a big argument that says that makes sense. The right product will find its space where it needs to be for the right use, for the right price, at the right time. Except that when you get a package from Structurlam, these beams are plus or minus 2 millimeters of accuracy. The steel is about 1/8. And the concrete, we always joke that if they're on the right site, you're lucky. So there's something to be said about going to a mass timber structure that is all produced in one facility that gets delivered to you, and it really truly goes together, plus or minus 2 millimeters. And we're starting to see that. There's also the argument that says that's too expensive, so we'll do a hybrid. We'll do a steel frame because glulam's still too expensive and certain, and then we'll put CLTs on it, and we'll do a prefab wall. We're seeing a lot of that happening, and I don't know, it's probably going to be a whole bunch of both as we cut our way through the jungle of mass timber. So we also got into 3D modeling. Generally, if you come to Structurlam and you want us to to supply a building to you, we will offer you the full meal deal. And the full meal deal is we will take 2D drawings that come from the architects, or we work in BIM. But generally, the ironic thing is that BIM is coming a long way with these central models, except with liability, nobody wants to actually stand behind the model. So we take a perfectly good model and redraw it because no one will take liability for it. So we take 2D and 3D. We start from scratch. We have 9 or 10 detailers. All they're doing is drawing in 3D CAD every day. And that is the central model that drives our whole project. So when we take drawings and we do a model that goes back to the consultant team, they sign their life away. All of the work when you're doing a mass timber structure with Structurlam is done up front. Because if we cut a beam and it gets fabricated and cut and end milled and 3D model and it gets to site and it's 2 feet short, we don't make a beam stretcher yet. That technology is not out yet. I know, it's horrible. We can't just scab on like steel. So we've invested heavily in 3D modeling software. We've invested, and then on top of that, in the mid to late 90s, we invested in a number of CNC machines. We just got our latest one a couple years ago. We'll talk about later. But this on the glulam side, we have 2 really good machines. One, many of you have heard of, it's K2 Hundigger, standard machine in North America. It's the workhorse. It takes wood and pulls it through it, and it has end milling and auger bits and cutting and tapping and sawing and grinding, and it's a good solid machine for straight pieces that are sort of say 10 inches by 20 inches by 40 feet long. That's kind of your limit. When you really want to get say funky, we always love architects that have really high budgets and creativity that want to do funky designs, because what it does is no one else can build it, so we can. and we can charge for it. So we have a Chrono, and the Chrono is a gantry style over machine, and it has a bay spacing of 50 feet wide by 110 feet long by roughly half a meter deep, and anything in that area, it can cut. So we always say, if you can dream it, we can machine it. And so we're going to see if this works. Is this going to work?
Possibly.
Maybe. It's not going to work. Oh yeah, it is. There you go. There's no sound. It sounds really cool. It's just loud. So it just gives you an indication of sort of what our machine can do. It has 20 different heads. I mean, this is really truly is big boys, big toys. I mean, when we take tours of our facility, we'll stand there for the day. But it's a fully automated. It comes from our 3D model, and it's fully. The heads change automatically. You set it up, and it will do exactly what you tell it to do. And if you tell it what to do wrong, it does it perfectly wrong. So that's the Chrono. So we've had the Chrono since 2003. It took us 2 years to figure out how to use it, and then it took us another 2 years to actually make money from it. And today, that machine generally is a key component of what we do, because what I sell to general contractors, talking about distribution channels, my distribution channel is direct to a general contractor, and my value proposition about why you'll do business with Structural Lab is I remove risk. I take risk away from your project. How boring is that for a sales pitch? But to a GC, absolute music to his ears. We also, in the early 2000s, combined our ability to draw in 3D, to tie that to a CNC manufacturing. We started getting into different types of connection systems and timber engineering. So, you'll recognize a lot of those connections, but I mean, a lot of this stuff comes from Europe, and we just are relatively quick to adapt. I'm not really big on reinventing the wheel. I really love to take what other people have proven and find a new market for it. So we've brought in a lot of new connection systems. Here, this is called a Bircher connection. It's a very, very strong moment connector. We use this on the Olympic Oval. The Olympic Oval was built for the 2010 Olympics in Vancouver. It's the longest span. We created beams that were 364 feet long, arches, 8 feet deep, 12 inches wide, in a big V, in 4 sections. The clear span was 300 feet, the arch was 364, but this connection allowed us to connect in moment. A lot of this is a Sherpa, but there's a lot of new connectors for the engineers out there in the room that are off the shelf, easy to use, easy to design with, that are really exciting, because we pre-install them in the factory, and they come on site, get dropped in, you're done. So a lot of the work is being taken off site and actually done properly in a facility. Yeah, again, the unions in New York don't like this stuff, but I'm okay with that. A lot of HBV mesh is another very interesting product from Europe that we've done a lot of work with, and that's steel, wood, and 2-part epoxy, and very careful measurement of 2-part epoxy to make sure that you have the bond. So we do a lot of that as well. And then custom connections. This is I'll show you. So if you combine all of that, you start to get what we consider world-class projects and world-class production in delivering one-off beautiful structures. So when Frank Gehry decided to build an amazing structure in Toronto, this is the Art Gallery of Ontario, it's a whole block, and he decided to do a building that looked like a piece of paper being ripped. Has anyone been to the Art Gallery of Ontario? Yes. This is an inspirational structure that I encourage you as wood people to go and spend some time in. They make great coffee in this room too, by the way. But there is 1,100 unique connections. Every single connection is individual, and this is what it looked like. This is the end. So this is a great place to spend time when you've had a hard day and all that health benefit stuff that Dave talked about. I can't think of a better room in North America than this room. So Frank Gehry, for as, I won't say crazy, but as unique a gentleman as he is with his designs, this was off the charts exceptional. So Structural Lamb plays in a lot of different arenas. I would say 90 to 95% of our business is non-residential construction. Pools, schools, transportation. Look, it's we're providing the frame for other products to go over. So the history of glulam in mass timber, and I want to touch on that in the U.S. two-step distribution, glulam competes against LVL, microlam, other structural composite lumbers through two-step for structural components only. In Canada, generally, particularly, if you're buying glulam, you are going to look at it. It is exposed because it's more expensive to buy generally than those guys that are pumping out 500,000 feet a day and $10 million of wood on the ground at all times in standard sizes that are going into the BMC West and the pro-build yards. Different business model than most of the Canadian market, and that is one-off buildings, custom manufactured, visual. Generally, a glulam that you get from a Canadian manufacturer is superior visually, equal to in structural, but far superior visually to a I-5 maybe glulam. These are the beams I was telling you about in the sporting facilities. We built six or seven, or we supplied 6 or 7 of the 10 main buildings that were built for the Olympics in Vancouver. And this structure here is a big private golf course that we built in Seoul, Korea a couple years ago as well. So once you have a system that you can package that is customizable to a particular building, we can ship it anywhere in the world, and we do. There are a lot of airports. Looking at David's presentation, there's a number of pictures of airports. I went, hey, well, yeah, we supply that one. You always look and see what you supply, right? In pictures, this again is an interesting structure. Raleigh-Durham Airport. That's the largest span glulam truss structure in North America and possibly the world. So coming out of little old Penticton. We do a lot of very interesting educational facilities. This is at UBC, different colleges, Ballard Library. We have a lot of fun with different products. And then we do residential, and we do it 2 ways. One, we sell direct to lumber yards. We do not go through two-step distribution, we go through one step. So garage headers and some exposed beams in your house. You can do a combination, traditional heavy timber house. We sell to the lumber yards, or we do a large custom packages. We do a lot of canopies and atriums as well. And this is the joke. This is what I find really interesting about, or the frustration about the world of heavy timber. I'm going to change in a minute to mass timber, but the world of heavy timber. And that is, see, in British Columbia we have this thing called wood first. And nothing for a guy who has to sell X many millions of dollars a year of glulam packages drives me more nuts that we have this wood first act that says if there is provincial money in a building, you basically need to prove that you can't use wood. Unfortunately, that doesn't really happen because as soon as a general contractor who only knows steel and concrete, the first thing they do is get the wood out of the building. So we constantly see 60, 70, $80 million structures with these beautiful canopies on them. And I get maybe $100,000 of an $80 million building. That's not a lot of wood. So we don't, we get the occasional frame. Our big challenge really, truly is retraining 100 years of concrete and steel. They did a great job, guys. They did a fabulous job. when Greg showed that picture of the old mill cutting studs, that was the turn of the century. And all of a sudden, because I'm a forester, that's my background, I'm a sawmiller, we looked south and said, we're going to cut all these sticks and we're going to build houses in the U.S. with them. We completely forgot about the non-residential sector. And over the years, what was the building that David showed us that was the 1905, the 17, 15-story structure downtown Vancouver, right? We didn't do that. And what happens is codes and education and all those sorts of things, we have to undo 100 years of steel and concrete to build more heavy timber structures. Now, particularly, I'm speaking for the West Coast. I can't speak for the East. Heavy timber, moving to mass timber. We've done some beautiful frame projects. I could sit here all day and show you really pretty pictures of buildings that we've been a part of that are a lot of fun to do, that we had to bust our butts to win the business. But what's really exciting from a manufacturer's perspective is that we're starting to see frames and floors and walls. And I always say that glulam replaces steel, crosslam CLT replaces concrete. The frame should be glulam in our world, if we're doing our job properly. And the components, some and or all, of floors, walls, and roofs should be mass timber. And from a guy who produces CLT, should always be CLT. That's my job. So this is very exciting. You're starting to see a shift. And when you have people that work for you that have to sell these buildings, and for the same amount of work, if I do my job properly, I can sell 5 times the volume of wood into a project. My commission just went up 5 times. Comp plans drive behavior in the real world, right? So as a salesman, this is very exciting. As a part of the industry that's taking all that data that David Gray presents and trying to figure out how to build a business around the data that's there and an industry that is way bigger than I am. But an industry that is there waiting for us to participate in it. And so, that to me for this room is the trick. Mass timber is coming. Mass timber is here. 6-story is here. Mid-rise is here. How do we figure out how to participate and grow our businesses to do that? Or if I'm in the government, how do I help support the businesses that do that? And if I'm an architect, how do I design with these new materials to make it easy within a building code to do that? So, the chasm. This is probably the story. I refer with my team and our company to this graph a lot. Where are we?
The Simon Sinek graph.
Yeah, it's crossing the chasm.
Yep.
Yeah. Okay. So this is from the IT world, right?
Yep.
Right. So this is the product maturity phase, and if I'm in the world of glulam, guess what? We've been doing this for a long time. But actually, I put another graph that starts here and goes here, because glulam has had this great new rebirth for all the reasons that David was talking about. So glulam is being used in new and wondrous ways, right? In CLT, this is how we started 5-6 years ago. Early visionaries, maybe some early adopters, right? There's some of you in this room. And when I talk about the people who actually build buildings with an unproven material, where you have to go down the alternate path route in a commercial construction because it's not in the building code, it's a very unique person. The market's not this. The market's this. Because I need an owner who has lots of money and patience, who's a little bit crazy. I need an architect who's not afraid to design in a new wood product that's unproven. I need an engineer who's not going to be so conservative that they're going to drive up the steel and the connectors so far that it's unbudgetable. And then I need to make it. If I'm lucky enough, I get to supply it because there's Europe and there's some other manufacturers. And then on top of that, I need to find an installer who's going to install it. And you said it earlier, Greg, an installer who's actually going to pass on the savings to the general contractor. Because they're going to say, I'm X dollars a square foot to install wood, but I'm only going to be there on a third less with a third less people, and I'm going to have no extra work, and I'm going to be on and off, but I'm charging you the full plot. Very, very frustrating and very difficult. So this is where we started out. And we started out making cross-laminated timber. In the world of mass timber, we did 4 products. You can buy 3-ply, 5-ply, 7-ply, and 9-ply. And we went back to the source, and we were talking with Paul there earlier, and we purposely designed our product around a commodity that has over 1,000 sawmills producing it in the West Coast that I can buy off the open market any day. SPF 2 and better. Random length. In theory, it should be there all the time, and I ride the ups and the downs. Because we're not a sawmill, we don't own forests, we're not vertically integrated. I am a true remanner and a true value add. I buy off an open market, I add value, I sell, and if I've done my job right, there's a gap called profit. So this is sort of the spec that we did. So the grade there is really interesting. Chu, are you going to talk about PRG and all that sort of stuff later? Or?
A little bit, yeah.
Okay. So as we develop a new industry that is way bigger than structural lam, a new industry, there's been some amazing things happen, and that is the U.S. and Canada have actually cooperated and created the PRG 320 for CLT, and that is third-party standards of manufacturing that allow me to be certified. That certification, same as if you're making any EWP, you need a stamp or a third-party structural stamp that says this building won't fall down. We've done a lot. I won't get into that. The other thing that we did is we created our very first design. This is Crossland Phase 1, early adopter, visionaries. Get out there, create a market, sell, and hope that things bigger than you are going to bring us along. How are we doing for time?
Good. You got about 5 minutes.
Yeah? Wow, I got a lot to go. We got certification. We did, the other day, one of my guys was telling me, we were bragging that we'd done about 100 projects. We've actually done over 200 buildings in the last 5 years in CLT across North America. Why use CLT? Two-way spans, versatility, exposed. Okay. All the environmental benefits.
Did you actually do environmental product declaration?
We have.
for
That is
your
actually for
products?
us. That is, we have an EDP that you can download off our website anytime. Minimal site waste. Rapid assembly. This stuff goes together fast. Easy assembly. Big difference. Rapid assembly, fast. Easy assembly. I can use fewer people that have less skill to assemble this if I do all the pre-manufacturing. Remote. We've done a lot of remote buildings with a very, very short building season. By doing all that work up front, it allows you to do some very unique structures very quickly. Top of a mountain, 2-month building cycle. 4 to 5 truckloads literally winched up to the top of the mountain to build this heli ski lodge. I wish I could tell you that it was the vice president of sales and marketing at Structural Lam that has single-handedly been responsible for the growth of the CLT market and our success. It's on my resume. It's not true. And that is, there's a lot of things a lot bigger than us pushing product onto the market. What has done it? It's been a combination of amazing support from the government, the creation of Woodworks, the research that Chewy is doing, and FP Innovations. The handbook. And really the big one for us in the marketplace, there's 2 things that have come along, and that's, I'm going to call it Crossland Phase 2. Is reference projects. I forget the other one. It's really important too. I'll get to it. The building code. The building code. Yeah. So there's a massive change in the building code. So detailing, getting more complicated, but you can see we're starting to get the whole building, not just the frame. And so one of the biggest things are the early projects in a combination of reference projects. So Earth Sciences building was one of the first ones. A big U-shaped building, cut in the middle, half steel and concrete, half mass timber. Guess where everybody wants to work? You guessed it. UBC Okanagan Fitness Center, again, like these are early structures. This is sort of cutting edge. Equilibrium Consulting, Fast and F Engineers, push the boundaries of design and showing us what's possible. A very stunning, and then this is using some of the HSK mesh and a lot of sort of cutting edge construction systems. One of my favorite early buildings, and this is about using big, large plates, 43 truckloads from Penticton to Fort Mac. Massive roof structure at the Fort McMurray Airport that, they allowed all the mechanicals to run through the individual connection systems there. One of my favorite structures to be involved in, and so everything you guys have seen to date has been what? Exposed wood. Architects, when I get a wood building, I'm going to use mass timber and I'm going to expose it. That's phase one. That gets us in there. Phase two is, I'm going to replace concrete. I don't need to expose it because I'm using it for all the other reasons that I showed you. And so the Ronald McDonald House was a combination of floors, walls, and roofs with 80% of it non-exposed. They used it for all the health benefits, for the fast construction, for the easy construction, for the predictability on site. So what happened? This market got created called mass timber. So we had to react. So while we're all out there trying to slowly get 0.000001% of a concrete market, all of our competitors on the glulam side and the mass timber side are creating new products. So enter the world of GLT, the rebirth of NLT. These are all, so we have this tiny market from nothing called mass timber to this slightly larger than tiny market called mass timber. And we have this monster over here called concrete. And today, where are we? All of us mass timber guys are beating the crap out of each other for this tiny little market share. So we now make a whole bunch more products. We make structured deck, which is a GLT. I mean, our focus is 99% cross-lam. But when we see specs come out, we're going to quote GLT. We're going to, and for NLT, which is an EWP producer, my blood boils when I hear about NLT. But it is a product. It is out there, and anyone can make it. It's called an EWP. I'm not sure why. But we make an engineered version of an NLT now, so we can bid it, and we still make our traditional glue laminate. So we crossed the chasm, I think, and trying to tie this up here with a couple minutes left. I think we crossed the chasm, and why? It's forced us to be more complex. As a market matures, you offer more products, more services as it segments, right? So we do now design assist, where we can help you design your building and take on and help you with your design. We can do full design supply, where we offer full engineering. We can do a traditional project where architectural specs are good and the engineering drawings are good and we just bid it. Or we can do custom fabrication services where somebody else takes on the modeling. I want to tie this into this group, and that is you can play anywhere on this continuum of product development. My favorite project is a 3-story, this is the Lakeshore project, it's an office building. It's glulam frame and CLT over, and they took advantage of some of the unique characteristics of crosslam. When they were building this in Kelowna, it stopped traffic. It was a spec building that was sold out 90% before they even finished building it. Whittick, I think maybe you've heard of it. Whittick is another fantastic reference project that was really expensive. So everyone talks about CLT in the mature market because as Canadians, we love to beat each other up rather than be proud of this building. We love to say, yeah, but it's so expensive. Yeah, but we did it. We built that building and proved you could go 7 stories with mass timber. And in this one, it's not only the floors and walls and roof, we did core. So we're doing elevator shafts in 2 and 3 days. Right? Pretty exciting. And these are some images of Whittick. I call this wood porn. Hey, engineering. I'm engineering corn. And this gets us all excited, right? When we talk in the room, when there's lots of funders and government agencies, we talk about tall wood. We talk about going higher. And 3 or 4 years ago, I believe this is Michael Green and Eric Karsh from EQ, put together the tall wood strategy, or they did a project on this, a paper. And fast forward 3 years, in May, we're starting installation of the first 18-story tall wood structure using glulam columns only, no beams, no purlins, and two-way spanning CLT. Using CLT in its true function of two-way spanning. This is the TSN turning point. We've long come across the chasm this proof for small span. So this is 10 to 12 foot spans. This is motel units. This is hotels. This is university dorms. This actually is a university dorm, and this is exciting. This is $192 a square foot, finished, installed. It stands on its own. It is not a reference product. It is an investor, University of British Columbia, who has proven that it's possible to be competitive in wood. Not 1 inch of this exposed. None of this is exposed, but you get all the benefits of it. There's a mock-up just completed. And just to conclude here, one of the things that I'm most excited about, and that is that we've been slashing through this jungle with a machete that we always joke about, trying to create a marketplace and find where CLT and glulam fit in the world of mass timber construction. And to date, I don't know, many of you are involved in the commercial construction sector, but you need to go down an alternate path. The hurdles aren't crazy. The amount of extra steps that you have an owner to go through to go down the alternate path is insane. Most don't have the patience or the money or the consultants, because you have to play, you have the building officials, you have fire code, you have water, you have acoustics. All of this is custom, because it's not in the code. 6 weeks ago, CLT was just put into 086. It's coming out in June. You're going to talk about it? A little bit? You'll mention it? Well, a little bit. For me, this is the journey is finally getting to be a little more predictable. These are the forces that are bigger than me and us, and that is the ability to work with this new mass timber product. I mean, never in the history of since the turn of the century has a building product been put into the building code faster with more rigor than CLT. So truly, in Canada, you want to see it succeed, and I would agree that in the U.S., it's already in the building code. The problem is that the jurisdiction haven't adopted it yet. That's a whole other discussion. So what have we done? We've launched 16 products now. Span to depth ratios, cost per span, so we can do industrial, non-exposed, exposed, and I have a solution for every, I have 12 more solutions than I did in phase 1 across lab, in 2.0 than we did before. This allows you to be more competitive. Really, this is about cost. I've shown you on this whole journey, bigger, taller, faster mass timber is more exciting. The reality at the end of the day is 80% of non-residential construction in Canada is still 2-story or less. So I'm going to stand on this speaking circuit and talk about tall wood, and I'm going to sell beautiful gymnasiums, community centers, 3-story office buildings. You don't need to be a tier 1 wood-based international scholar, structural engineer to work with mass timber anymore. That's my message to this group is that there's been a whole lot of work done around this new industry called mass timber, and now it's for you guys to figure out how you think you can play within it to be profitable as it comes to market. I think that's all I have.
You got a lot. Thank you very much, Steve.